Hello, I am Dheeraj. Welcome to my channel. Imagine you are managing a virtual team of AI agents. One agent books your meetings, another analyzes your emails, and a third helps with your travel. Initially, everything runs smoothly until your meeting agent double books you with your doctor's appointment and your AI finance agent overspends on flight booking. Therefore, you realize something. It is not enough for AI agent to be smart. They must also be reliable teammates. Welcome to the world of agentic AI evaluation, the science and art of measuring how well autonomous and multi-agent systems perform, collaborate, adapt, and learn. So, let's get started. Before going into evaluation of AI agents, let's quickly discuss few fundamental concepts. An AI agent is a software program that can perceive, reason, decide, and act on its own to achieve a specific goal. You can think of it as a self directed mini AI worker. Agentic AI is a design philosophy and framework for building AI agents that can think, plan, and act intelligently. The agentic AI systems are often powered by LLMs or large language models. A multi agent system or MAS is a network of multiple AI agents that interact, collaborate, or compete to achieve complex objectives. MAS introduces the concept of collective intelligence, where many small, specialized agents coordinate to achieve broader goals, just like teams in a company. We are going to discuss top 10 metrics to evaluate an agentic AI system. Let us discuss the task success rate metric first. This is one of the most fundamental metrics. It tells you if your agents are actually getting work done. Task success rate is the ratio of successfully completed tasks to the total task assigned. It matters because it gives a quick snapshot of system reliability. If task success rate is less than 80%, it is considered low and the agentic system needs improvement. This metric shows how efficiently the agents are completing their assigned tasks. We divide the number of completed tasks by the total task assigned to find the success rate. A higher score means the system reliably achieves its objectives without failure. The error recovery rate measures how effectively an AI agent can identify and fix its own mistakes without external guidance. It reflects the agent's self awareness and autonomy that is a key trait of agentic AI systems. A higher ERR indicates greater reliability and adaptability. For production grade agentic systems, for example, autonomous coding agents, financial assistants, or customer support bots, an ERR above zero point 0.7 is generally considered reliable, especially if accompanied by high task success and safety scores. The error recovery rate measures how well agents self correct their mistakes. Here, we calculate the fraction of detected errors that we successfully recovered without human help. It reflects the agent's resilience and self healing capability. Average response time reflects the efficiency and latency of the agent, important for evaluating real time usability. This is especially useful in conversational decision making or autonomous task environments. Low ART indicates fast reasoning or execution. This is good for real time interaction. High ART suggests delay, possibly due to complex reasoning, multi step workflows, or inefficient tool use. Average response time tells us how quickly an agent reacts to incoming requests. We take the mean of all recorded response times in seconds. Lower values indicate faster and more responsive agents. Conflict resolution rate measures how effectively an agentic AI system can detect and resolve conflicting goals or actions on its own. This is expected without external guidance or human intervention. In multi agent or goal driven systems, agents often face situations where their objectives overlap, contradict, or compete. A high CRR indicates strong autonomy and coordination capabilities. A high CRR, for example, more than 80%, suggests the system is good at self coordination and policy alignment. This is essential for large scale multi agent or enterprise AI orchestration systems. For example, imagine a banking agentic system where Agent A wants to maximize customer engagement by offering credit card upgrades. Agent B wants to minimize financial risk by tightening credit approvals. These goals conflict. One wants to approve more offers and other wants to decline risky ones. If the system can autonomously negotiate or adjust priorities to find a balanced decision, say approving offers only for low risk customers, it has successfully resolved a conflict. This measures how often agents resolve conflicts among themselves. Conflicts can occur when agents have overlapping goals or limited shared resources. A high rate shows that agents can reach agreement without external intervention. Now, let us discuss the agent's collaboration efficiency. Collaboration efficiency evaluates how effectively multiple agents share information, coordinate, and complete tasks together. In a multi agent setup, collaboration efficiency reflects communication clarity, conflict resolution, and information sharing latency. It matters because poor collaboration causes duplication, delays, or logical conflicts among agents. For example, a high value greater than zero point 0.8 indicates smooth coordination. A low value less than zero point 0.5 indicates poor communication. Collaboration efficiency measures communication effectiveness between agents. We calculate how many exchanged messages were actually useful for task completion. Higher efficiency means less redundant communication and better teamwork. Autonomy score measures how independently an agent can make decisions without human intervention or external guidance. A highly autonomous agent can plan, execute, and adapt actions on its own. However, a low autonomy agent constantly asks for permission or external feedback. Autonomy score matters because it directly affects scalability. The more independent the agent, the less human supervision is required. The autonomy score shows how independently agents can act without human guidance. We find the ratio of decisions made autonomously to total decisions made. A higher score means the system exhibits stronger self governing behavior. Resource utilization efficiency measures how effectively an agent uses computational and memory resources while completing its task. It matters because efficient agents can run on smaller devices and scale across many users. Higher resource utilization score means better efficiency. A high value greater than zero point 0.8 indicates smooth coordination. A low value less than zero point 0.5 indicates poor communication. This measures how efficiently an agent uses computational or environmental resources. We compare the resources actually used versus those allocated. Better efficiency means the agent completes tasks with minimal waste. Adaptability index assesses how effectively an agent adjusts to changes in environment, data, or task conditions. It matters because in real world systems, conditions change. Data shifts, APIs fail, or user preferences evolve. A good agent adapts gracefully. An adaptability index greater than zero point 0.8 indicates high adaptability. An adaptability index zero point 0.5 to zero point 0.8 indicates moderate adaptability, and an adaptability index less than zero point 0.5 indicates the agent struggles to adjust. The adaptability index measures how well the agent improves when conditions change. We calculate the performance gain after adapting to new tasks or environments. A higher index means the agent learns or adjusts effectively over time. Knowledge retention and utilization metric measures how effectively an agent recalls and applies prior knowledge to new tasks. It matters because agents that forget past information must relearn constantly, wasting time and resources. A value of 1.0 indicates perfect retention and reuse. A value less than zero point 0.7 indicates knowledge degradation. This evaluates how much of what the agent learns is actually applied in real tasks. We take the ratio of knowledge used versus knowledge learned. High utilization indicates good memory retention and effective reuse of experience. Explainability and interpretability score measures how transparent and understandable the agent's reasoning and decisions are to humans. It matters because trust and compliance are important. In finance, healthcare, and law, you must explain why a model acted in a certain way. The explainability score tells us how many agent decisions are understandable by humans. We compare interpretable decisions to total decisions taken. A high score means the system's reasoning is transparent and trustworthy. If you are interested in exploring more concepts about machine learning, data science, and large language models, please find the links in the description of this video for more concepts, questions, and answers like this. Building agentic AI systems is like assembling a digital orchestra. Autonomy is the melody, collaboration is the harmony, and adaptability is the rhythm. But without evaluation, you are just listening to noise. With these top 10 key metrics and Python tools, you can turn that noise into measurable and intelligent performance. This makes your agentic AI systems smarter, safer, and more human aligned. Thanks for watching. I hope you enjoyed this tutorial and found it insightful. If you learned something new, please like the video, share it, and subscribe to the channel. Also, consider sharing your thoughts in the comments below. Please don't forget to subscribe for more interesting tutorials and the latest updates. For more interesting questions and responses like this, please follow the links in the description of this video.